What's up everyone? Now let's see how to deploy symmetric inter-VNI routing, and I'll be referencing the Cisco MP-BGP EVPN control plane design guide. Now if you take a look at this picture, it's easier to understand the workflow on symmetric inter-VNI routing. So let's say that VNI is what we are using as VNI 12310, and VNIB it's VNI 12320, and this is VTEP or leaf 2, and this one is leaf 1, and this will be router 5, a host that is connected on the VTEP, and this is going to be router 9 or router 7 whatsoever. So the difference is with symmetric routing, we don't have to configure VNI A and B on all VTEPs, on leaf 1 and leaf 2. We're going to create a new VNI, and that's going to be a layer 3 VNI that will be used to route the traffic across these different VNIs. So the traffic will be routed into this layer 3 VNI, and we'll be using VRF to segment the traffic for a specific tenant or a customer. And as each VTEP will have this VNI, the traffic will be bridged inside this VNI, and then it's going to be routed to the destination VNI. So it's simpler and easier than asymmetric inter-VNI routing. And right here at the bottom we have some explanation. I strongly suggest you to take a read on this one, and we'll be still using Anycast gateway as well. Here we can see the configuration. Essentially this is something that we have done already. So building the VXLAN or overlay for underlay or SPF, multicast, and interface VLAN. And what I want to highlight here is that we're going to create the VRF context for each tenant, and we're going to associate these new VNI, the layer 3 VNI, with these VRF contexts, so that all the layer 3 networks for a particular customer will be inside this VRF. And inside BGP, this is the next step, we are going to advertise what is it? We're going to advertise those networks, and we're going to see this in a moment. So let's start with leaf 1. So on the spine I didn't make any change, so we're just going to focus on leaf 1 and leaf 2, and I changed the topology a little bit. So right now we'll be using R5 and R7 only, and R5 will be on network 192.168.10, and its gateway will be 10.254, and it's only here on leaf 1. As for R7, it will be on network 192.168.20.0. As for R7, it will be on network 192.168.20.0, and its gateway will be 20.254, and it only exists on leaf 2. So let's begin with the configuration on leaf 1. So I'm going to enable all the features just at once. So we'll start with OSPF, multicast, and interface VLAN, and BGP, and to support VXLAN, VN segment, and feature NV overlay. And we have to enable support for EVPN. So NV overlay EVPN, and we're going to use VRF, but just in a moment. So first let's enable OSPF and multicast. So router F1 RID 192.168.0.1. I want to log the adjacencies and on console as well. For my loopback interface, 192.168.0.11.32, enable OSPF 0 and enable multicast. That's the interface. So we're just going to enable one interface because we are not using spine 2. So we're going to make this a layer 3 interface. I'm going to enable the interface and we handle jumbo frames 2216, and because we want to use the loopback interface, loopback 0, median, point to point, and IP unnumbered the loopback interface. Going to enable SPF and multicast. It looks like OSPF done. Yes. Duplicate router ID. Confirm. Oh, I bet. So router ID is 192.168.0.11. Should be fine now. Okay, so OSPF adjacency should be established. Went to full. Yes, done. I should have OSPF route 01 and 112. Okay, so now let's create, so configure the RP. It's going to be 112. This is done. So multicast and OSPF, those are done. Now BGP and neighbor will be 192.1.1, remote 64.512, and we want to update this from loopback, and we'll be using L2 VPN address family and EVPN, and we want to send both community. So this is done. Let's check show BGP, L2 VPN, EVPN summary, and adjacency is established. So BGP VPN is done now. So let's start building VXLAN configuration as well. So to create VLAN 10 and VNI will be 123N, and we're going to create already the layer 3 VNI that will be used to route the traffic between different VNI. So we're going to use 30 and VNI will be 123.30. Now I'm going to set the Anycast gateway, fabric forwarding Anycast gateway, and the MAC address will be 65745. And we're going to create the VRF that's going to be part for this tenant or customers. We're going to name it CCI1, and we have to associate with the layer 3 VNI 123.30, route distinguish auto, and inside AF address family IPv4 set the route target for both auto and for EVPN as well. Now for let's see, our layer 3 interface, going to enable and associate with the VRF PCIe, VRF member CCIe 1, and the IP is going to be the gateway, so in this case 10.254.24, no shot, just to make sure, and fabricast forwarding mod Anycast gateway. for host mobility. And let's do the same for VLAN 30. It's going to be member. So first is VRF member CCIE 1, and we have to enable the interface, and we don't have to assign the IP address as we saw here in the example. They pass already. On this that's going to be to route the traffic. This VNI. VNs. Find the layer 3 VNI. No, it's here. So it's using VNI 3900. So we just have to enable IP forward. So back to our configuration. Let's confirm that the interfaces are okay. So it's enabled. It's part of the VRF, the IP, fabric, and guest gateway, and our layer 3 VNI is enabled as well. Now, the interface facing R5 is going to be an access port and part of VLAN 10. So I should be able to ping 10.5 on VRF CCIE 1. That works. Okay, that's awesome. Okay, so we're about to finish. So now let's create a VTEP interface. Going to enable the interface. We're going to source this from our loopback interface, and host protocol is going to be BGP. Now, VNI we'll be using is 123.10, and the multicast 224, 65, 74, 5. And the other one, the layer 3 VNI, is going to be 123 and 30, and we're going to use associate VRF. Let's confirm that everything is okay. So the host protocol is BGP, sourcing from the loopback, that's the multicast group, that's okay. Let's confirm that interface is up. It's up, great. So now for EVPN, that we're going to use to advertise, it's going to be 123.10, layer 2, the route distinguish auto, and the route target for both is auto as well. Now for BGP 64512, inside the VRF, we want to advertise the network that is part of VNI 123.10. So with this in place, we look at BGP, L2 VPN, EVPN, summary, established, and I'm adding R5 into layer 2 VNI 123.10, and we can confirm as well by looking our layer 3 VNI network that we are advertising. We're going to do the same process, the same steps on Leaf 2. So first enable the feature, so grab this to save time, copy all of these, paste, and NV. Now this is for EVPN. Okay. And for BGP, going to be almost the same thing, except okay, let me start. Okay, so let me start with SPF. Router ID 192.168.0.12, and want to enable logging on console and configure loopback interface 192.168.0.12. Going to enable OSPF 3.0, enable multicast, and interface that connects to spine 1. We want to enable the interface and enable layer 3 MTU 92.16 IP route OSPF 301 IP. It's missing medium point to point IP unnumbered loopback 0 IP theme sparse mod. Okay, let's confirm the configuration. Enable point to point loopback OSPF means that we should be OSPF neighbors now, and we should have OSPF routes, and we can. Okay, that's great. And now multicast EVPN RP 192.168.0.112, and it's done. And now let's start using BGP. So BGP is going to be the same thing except for the network and VRF. So let me start by creating the VRF context. Actually, let me start with the VLAN. So VN segment 123 is going to be 20 and VLAN 30. That's all we need. We don't need VLAN or VNI 123.10. So we just need the layer 3 VNI, and VN segment is going to be 123.30. Now let's create VRF context CCIE1, and we're going to associate with VNI 123.30, route distinguish auto, and address family IPv4. Route target going to be auto for IPv4 and EVPN. Now fabric, because we're going to use Ncast gateway, fabric forwarding Ncast gateway. It's 065745, and no, my mistake, not 10, it's 20. VRF member PCIe1 or shut. The IP will be 192.168.20.254.24, and fabric Ncast fabric forwarding mode Ncast gateway, and we're going to do the same for layer 3 VNI and VRF member ECCIE1 no shut. Going to enable routing on the interface, and let's confirm from 10 to 30. So we have the IP, enable Ncast gateway, and we have our layer 3 VNI. Now let's see where my host is connected. It's going to be an access port and part of VLAN 20. I should be able to ping 27 VRF CCIE1, and I can. That's awesome. Now let's see our VTEP interface. Is it already? Not yet. So let's start. Going to enable the interface. We're going to use our loopback interface to source the traffic, and the protocol will be BGP, and member VNI will be 20, and the multicast group for this VNI will be 224.65746, and our layer 3 VNI it's 123.30, and we have to associate with the VRF. For EVPN, the VNI 123.20 layer 2, going to assign route distinguisher automatically. As for route targets, both values will be derived auto as well. So for BGP, what is left? BGP 64512. Don't see BGP. Oh, I haven't done yet. Okay. I selected, yeah, but I didn't paste. Okay. So it's going to be 01 remote 64512. We're going to use our loopback interface, and address family is going to be EVPN, and we're going to send both communities. And for our layer 3 VNI inside address family IPv4, we're going to advertise network 20. So let's confirm that VTEP interface is up. Awesome. Can we see other peers? Yes, we can. This is leaf 1. It's MAC address or router MAC. And awesome. So show NVE VNI actually. So BGP, L2, VPN, EVPN, VRF, and CCIE1 should see network 10, 20, and R5 MAC address and IP being injected. So this means that R5 and R7, they should be able to reach each other now. So right now my gateway is 10 to 54, and for R7 is 20 to 54. Well, if I ping 27, that works. And it's working. So I hope you guys enjoyed this one, and I'll see you in the next one.